In A-Star Lab, we have a state-of-the-art seismic testing facility with a shake table which can test the structures up to 50 tons of mass and a pseudo-dynamic test system. Using this facility, this lab has created earthquake protection devices which are called as passive energy dissipation devices and base isolation devices. These structures effectively protect a structure and take out the energy of an earthquake from damaging the structure and also isolate the building from the damaging earthquake effects.
The energy absorption or dissipation devices protect the structures from seismic forces. This is possible by adding the devices in the superstructure. It primarily improves the fundamental damping of the structure and also increases its stiffness. And this concept is called passive energy dissipation. This institute has developed damper devices, namely metallic yielding damper device, lead extrusion damper device, rubber-based viscose elastic damper device, and shape memory alloy wire damper device. Dynamic characterization studies were carried out at element level. Installations of these dampers were also successfully made on full-scale structures to establish design guidelines. Based on the expertise gained, 2 Indian patents were filed. Seismic protection is also possible by making the structure flexible, by adding base isolation devices between the superstructure and substructure. It primarily filters the earthquake energy and also increases the damping of structure. This concept is called seismic base isolation. Laminated rubber bearings, shortly called LRB, were developed at our research center using indigenous know-how for seismic isolation applications towards structural seismic protection. Dynamic characterization studies have been carried out on these LRBs for a large shear strain using the dedicated seismic isolator testing facility exclusively developed for this purpose. Structural implementation of such indigenously made seismic base isolators were also done on structural models through which design guidelines and design charts were developed for seismically isolated structures of low to medium rise height. Here we see a dedicated team of scientists and engineers discussing the development process of a damper device. Public Works Department, city development authorities, construction industries, and other related stakeholders for developing seismic disaster-free smart cities can benefit from the use of these technologies. These technologies are also ideal for constructing lifeline structures like hospitals, power plants, and critical infrastructures, which are functionally essential services during and after earthquake. The products damper device and seismic base isolator device developed indigenously are well suited for the government's Make in India initiative. Disaster-resistant, innovative, lightweight prefabricated building systems